All right, so with number 4, how else could you find the area besides the way that you guys did it where you made like the outside shape and subtracted the triangles? You could use the distance formula. If you had to find the perimeter, which you will at some point, then what will you have to do? You have to use the distance formula to find the perimeter. So if I were finding the perimeter of something, you found the distance formula of the opposite sides and then do what? Add them up together. So add up all the sides for perimeter. So perimeter, again, is when we add up all the sides. Area tends to be some type of multiplication, but we have a lot of different formulas for area. What shape was it that this ended up making for number 4? It made a kite. Yeah, it made a kite. So the two, like if you look at, whose is that? Maria's? Maria's. If you look at Maria's, you can see the left sides, those are congruent, and then the 2 right sides are congruent. So if you were doing the perimeter of that one, how many distance formulas would you have to do? 2. Only 2. All right, only 2 of those. And then once you found them, you would add up all 4 of the sides. What's the formula for area of a kite? D1 times D2 divided by 2. Good. D1 times D2 divided by 2. So if you were going to find the area using the distance formula there, you'd also have to do the distance formula for D1 and D2. So again, it's not that I don't recommend that. That works just as well. It just depends on what you think is faster and what you think is easier. If you don't have a coordinate plane, I think sometimes doing it the way that most of you guys did on the board can be a little tricky because, again, when any human draws a coordinate plane, are you drawing it perfectly? Not necessarily. So if you try just counting the spaces, you might make mistakes. So that's why I say label the actual coordinates that you draw, because then you can just subtract them to find how long those triangle sides are. Okay, so we're going to talk today about a couple different things. We're going to do effects of changing perimeter and area right now, and then next we're going to do geometric probability in the second class, and then you guys will have a review, and your test will be on Friday. It's not going to count for quarter 3 though, because I'm not going to, like if I give it to you Friday, you wouldn't have time to retake it if you don't do well, so it's not going to go in until quarter 4. So your quarter 3 grades, once I put in the quizzes, I'm still waiting for a couple people to finish those. Some people are doing it next period. No. You all right? Okay, so I'm still waiting for a couple people to finish those. No, neither of you showed up in office hours. You're coming at lunch. You were supposed to be there. No, you said you were going after school.
No, I told you, remember we talked and you're like, oh yeah, if you're for sure going at lunch. Okay.
Oh, that's right. That's true. That did happen. Okay. All right. Okay, so I will see you at lunch. Anyway, so some people have not taken the quiz. Once they do, I'll put the quiz grades in, and that will be your last grade for the quarter. So I will get those in no later than lunchtime today, and then once those are in, if you need to retake that, make sure you do it by Friday, because the quarter does end on Friday. So we will have a review on Thursday, a test on Friday, and then we will be done with Chapter 9, and we're going to move on to 3-dimensional shapes. Okay, so effects of changing some dimensions. What is a dimension? What does that mean? Like if I tell you you have a rectangle and the base is 7 and the height is 12, what are the dimensions? Height and base. Yeah, dimensions are just the measurements. So dimensions of a figure are just measurements about that figure. So in this case, I want to describe the effect of doubling the height of the parallelogram to the right. So what is the height of this parallelogram? 9. The height of the parallelogram is 9 because it's perpendicular to the base. It's actually kind of turned like this. So that might make it a little bit more obvious that 9 is the height. That's not perfect. I didn't turn it quite the right way. But so the height is 9 and the base is what? 12. So how would you find the area of this figure? Base times height. What's 9 times 12? 108. So the area originally is 108 meters squared. So I'm going to say OA, that's the original area. What would happen if you doubled the height? Yeah, so now the height becomes 18. So what's the new area? Is it? 216 what? Meters squared. Okay, so when you doubled one of the measures, we doubled the height. What happened to the area? It also doubled. What do you think would happen if you doubled both of them? Well, let's find the new area. So it would still be 18 because that's already doubled. And then the 12 would become 24. So what would that area be? 432 meters squared. So what happened to the area if I doubled both of them? Quadrupled. So it multiplied by 4. If I only double one of them, what happened to the area? It only doubled. Yep, so it doubles if you increase one of the dimensions, and then if you increase both of them, it quadrupled. So when you're doing these problems, the effects of changing one dimension, the question says describe the effect. The effect would be, you would say, like the answer we're looking for here would be the area doubled or the area quadrupled. Okay? If you don't want to use those words, you can just say the area was multiplied by 2. All right, or the area was multiplied by 4. But you're not just looking for the new area, you're looking for the description of the effect. So you've got to actually describe in words what happened to the old area, new area, when you change the dimension. Okay, so this shape is what? A triangle. The base length of the triangle is multiplied by half. Describe the effect of this change on the area of the figure. So before I figure out what the new area was, what do I need to do first? Find out the original area, right? So the original area of this triangle, what's the base of the triangle originally? 5, and the height is 4. So what would the area of the triangle be? 10. Because base times height divided by 2 for a triangle. So base times height divided by 2 gives me 10. And then it says the base length of the triangle is multiplied by half. So which one changes, the 4 or the 5? The 5. So what would the 5 become if it's multiplied by half? 2.5. So the base becomes 2.5. And my height is still 4. So what would my new area be? Would be 5. So then if you were describing the effect, what would it be? The area was divided by 2. Or the area was cut in half. Because it said the base of the triangle is multiplied by half, and 5 times 1/2 gives you 2.5. So it just says the base length. If it said the base and the height, then you do both. And then that would be a different effect. Does anybody have a guess on what the effect would be if you multiplied both of them by a half? Well, it's already divided by 2. So then the area would be cut in 4, or divided by 4. Okay? So if you just change one dimension, it's only going to change by that amount. All right? So if you cut the base in half, and you're only changing one dimension, the area was cut in half. Okay? Just like over here, if we doubled one dimension, then that means our area doubled. So when you change one thing, whatever your area was, the same rule applies to your new area. Okay? So you don't even really have to find the new area. If you're changing one dimension, just multiply it by whatever your dimension change was. I also, if you don't want to, if that doesn't click, you don't remember that, you can always do this. It doesn't take that long to find the old area and the new area. Okay. So I want to describe the effect of each change on the perimeter or the circumference and the area of the given figure. So in this case, we're either talking perimeter or circumference. Circumference would be if it were a circle. This is a rectangle, so we're talking about perimeter. So we're talking about perimeter and area. So we'll do perimeter first, and then we'll do area. The base and height of a rectangle with a base 8 and a height 3 are multiplied by 5. So what's the first thing I need to do? What's the first thing you have to do? Find the original. I'm going to, even before I try to find the original, I'm going to draw a picture of it because it helps me visualize. So I've got a rectangle with a base of 8 and a height of 3. So what would my original perimeter be? Original perimeter. 22. Because 8 plus 8 is 16, and 3 plus 3 is 6, and 16 plus 6 is 22. Okay, what about my old area? 24 meters squared. All right. So then am I changing one or both of the dimensions here? Both. And they're multiplied by what? 5. So the 8 becomes a 40, and the 3 becomes a 15. So what's my new perimeter? 110. And what's my new area? What's 40 times 15? 600. So 600 meters squared. So then it says, describe the effect. So now what's the answer to this question, really? The area and perimeter are multiplied by 5. So the area and the perimeter are multiplied by 5. Is 22 times 5 110? Yes? What about 24 times 5? No. So that one's not multiplied by 5. What's that one multiplied by? Yeah. We'll talk about why in just a second. It's multiplied by 25. So the effect of the perimeter is still just multiplied by 5, but the effect of the area is multiplied by 25. Does anyone have an idea why that would be? What? Yeah, so 5 squared is 25. So how come the area is increased by 5 squared, but the perimeter is only increased by 5? A perimeter is just adding. It's just one dimension, right? You're measuring the line basically around the outside, so you're only measuring a one-dimensional shape. I know that this looks like 2 dimensions, but really you're measuring that straight line. But with area, you're measuring how many dimensions? 2. So you've got to square whatever your rule was because you changed both of them. Again, what? Like, could you square it? Yeah. Mm-hmm. So could you, like, not do this, square that, and say, okay, I need to multiply that by 25? Yes. Again, though, I think it tends to be easier if you just do it and then figure out what it is. So we're going to talk about, like, what the rule is, but it's easier for me if I can actually visualize what the old and the new are. Okay. All right, what about B? The radius of A is multiplied by 1/3. So what are my change in dimensions here? What's my original circumference? What would my original circumference be? How do you find circumference? Pi 2r. So it would be 18 pi. All right, what's my original area? 81 pi. What's my new circumference? What happens if I multiply by 1/3? It's the same as doing what? Dividing by 3. So my radius becomes 3. So what's my new circumference? 6 pi. And then what's my new area? 9 pi. So what's the change in dimension for perimeter there? Divided by 3, but what's the change in dimension for area? Divided by 9. So again, what's the difference? With perimeter, it's the same. But with area, what do you have to do? Square it. Yeah. So 1/3 squared would be 1/9, because 1/3 squared equals 1/9. So then you would take 1/9 for the area. Okay? So a change in perimeter or circumference, the rate stays the same. Whereas here, the rate of change is squared. All right, so whatever your rate was, Now your rate of change is squared if it's area. But for perimeter or circumference, it just stays the same. And again, that's because it's just a one-dimensional measure. Okay, go try these 5. This at the top is just telling you what I just wrote. So this stays the same. This one means the factor is squared. Go try those 4 at your boards. Remember, the answer is an actual description of the change. All right, so when you change the diameter, or I'm sorry, not the diameter, the radius, the circumference is still multiplied by 1/4, but what happens to the area?
You divide it by...
Not 4, but 16. So you square that number and divide it. So when you're only changing one dimension, like we did in numbers 1 and 2, you're just going to keep the same rate of change. So if you're only changing one dimension, you keep the same rate of change. When you're talking about perimeter and area, then you're looking at doing the perimeter stays the same, but the area changes by a factor of a squared. So whatever your change factor was, square it. Okay, so a square has a side length of 5. If the area is tripled, what happens to the side length? So before we do anything with the new area, let's do the old one. So I'm going to draw a picture of this. A square has a side length of 5, which means what's the area? 25 centimeters squared. All right, and now if the area is tripled, so in our new square, what's the area? 75 centimeters squared. So how would you figure out the side then? Square root of 75. So what's the square root of 75? Should be somewhere between 8 and 9, right? 8.66. All right, so 8.66. So then what happened to the side length? Was it increased or decreased? It was multiplied. It went from 5 to 8.66. What was it multiplied by?
By 1.73.
1.732. So you would say multiplied by 1.732. All right, so this is your change in side length. Okay, if you want to just do the old side length and the new side length, that's fine. But make sure you make some comment on if it was multiplied or divided. If it were divided, the shape would have gotten what?
Bigger.
If it were divided, the shape would have gotten smaller. If it's multiplied, that means you're talking about an enlargement. All right, a circle has a radius of 6 inches. If the area is doubled, what happens to the circumference? So my original circle has an area, or I'm sorry, has a radius of 6 inches. So if my radius is 6 inches, what's the original area? Pi. All right, and I said this to a couple people. I would leave all these in terms of pi. It makes it a lot easier to see the dimension changes than if you put them into the decimal. Okay, so if the area is doubled, so what's my new area? So my new area is 72. How would I figure out the radius if my area were 72? Square root it? Because what happens to the pi's? They cross out. The pi's are gone. So then, yeah, I just need to square root it. So what's the square root of 72? 4 what? 9. So 8.49 equals R. So what would I do then? Is that a multiply or divided by? It's a multiplied by. How do I figure out how much it's multiplied by? No, that would be added, 2.49. But I need to multiply or divide. So yeah, so just do 8.49 divided by 6. So it's multiplied by 4.1. 42? 1.42. So that's my change in dimension. All right, so again, this is the answer. This 8.49, like new radius, you'll get some credit for having that, but the actual question is saying describe the change in dimension, so you've got to actually describe what's happening there. Okay, questions on those changes in dimensions? All right, go ahead and do your exit ticket. If you finish with your exit ticket, you have until the next class, so just get whatever you need to get done.